Today we're going to be talking about how to connect this Stratux ADS-B in device to the MakerPlane EFIS. I'm starting with a brand new fresh copy of Ubuntu Linux version 20.04. There are newer versions. There was just a 23.04 released, but the 20.04 is a pretty stable version, and I use it. I've been using it for years now, and it seems to work really well with MakerPlane packages, so I'm just going to use that. You're free to try a different version if you want, but your mileage may vary. Starting with this new fresh copy of Ubuntu, I'm going to go ahead and open up a terminal. You can just hit the Windows key on your keyboard if you happen to have one, and then type in term, and then I'll usually right click on it right here and say add to favorites and hit escape, and then that brings the terminal menu over here onto my sidebar. So I'm going to go ahead and click on that, and from here the first step is to install something called Git. So if I'm looking over here at this GitHub, the MakerPlane repository, I can use a program called Git that allows me access to pull data from this repository. So the first thing I'll do is install Git. So we're going to type in here sudo, which gives me administrative privileges, and then apt-get. Apt is a way that Debian-based Linux distributions like Ubuntu, it's a way to easily install packages or programs for your use. So sudo apt-get, I'm going to install, and then type git, G-I-T, and then hit enter. It's going to prompt you for your password, just to make sure that you really want to do this. Alright, and so now Git has been installed on my computer. So the next thing I'm going to do is come over here, and we want to next install Pi Qt5. Qt is it's a library in C programming that allows you to make nice graphics and things like that. It's been ported over to Python, and that Python port is called Pi Qt5. There's different versions. There's a Pi Qt6 as well, but the ones that we're going to use for the MakerPlane programs is going to be Pi Qt5. So we'll go sudo apt-get install Python 3-Pi Qt5. Okay, so that's now been installed. Next we're going to install pip. If you're not familiar with what pip is, Python is a programming language, and pip is a nice little add-in, I guess you'd call it, for Python that allows you to easily download libraries that you might use in Python programming. So we're going to use that to pull in some necessary libraries for the MakerPlane suite of applications. So we'll go ahead and type this in. Sudo apt install Python 3-pip. Alright, and then next we're going to use pip to install one of those libraries that we need. So we're going to type in pip 3, because we're using Python 3, so pip 3 is for the version of Python, which is version 3, which is what we use. So pip 3 install geomag. So go ahead and hit install. So the next thing we want to do is come over here to the GitHub for MakerPlane. It's https://github.com/MakerPlane. Go ahead and hit enter from here. Click here under repositories. The first one we want to find is the fixed gateway, which is right here. The fixed gateway is the kind of central nervous system of all of the MakerPlane suite of software. The fixed gateway has a database that holds on to all of the different types of messages that you can send across your CAN bus or in any other. You can actually use it for several different things. It doesn't have to be just CAN bus. Just think of the fixed gateway as kind of like this back-end service that runs that sort of handles all of the different types of fixed messages that might be coming across. So what we're going to do from this repository here, we're going to come up here and click where it says code, and then click on this little copy button right here. And what this is going to do is we're going to be able to use that Git software that we installed a minute ago to pull this repository into our computer here. Now, if you're not familiar with Linux, Linux is Unix based. So if most people are at least familiar with Windows, your C/hard drive folder is sort of like the beginning of where you start everything. In Linux, it's a little bit different than that. We use just a // different than the backslash, a // so everything starts at slash and then something else from there. When you look on my screen here, you'll see this little tilde. What that actually shows is that I'm in my home directory. If I type in this command pwd, it'll show you where I am in the file path here. So from beginning at the slash, that's kind of like I said, it's kind of like the beginning of your C drive on a Windows computer. So slash home is a folder or a directory on the computer, and then slash MakerPlane. My username on this computer is MakerPlane, and this is a good place to actually do all of the work that we're going to do here. When you open up a terminal, it's going to automatically open to your home drive, and that's great. So from here, again, I'm going to come over here to my MakerPlane window. I'm going to click on this little copy icon here. That's going to copy what's inside of this little box. So I'm going to type over here in my terminal window, git space clone, which means to reach out and grab everything from where I'm going to point you to here in just a second. And then I'm going to right click here and say paste. It's going to paste that line of URL right there that we just copied a second ago. And then I'll hit enter. And that's going to reach out to this GitHub repository and pull down everything that's inside of here and make a copy of it into a new folder on my computer. So if I click here, you should be able to see I'm in my home drive. And you'll see that there's now a Fix Gateway folder here. And if you open it, it's going to look very similar to what you see over here. It should have all the files there as well. So from here, I want to type cd space fix-gateway. And in Linux, if you type the first couple of letters and hit the tab key, it'll try to finish it up for you. So I'm going to go cd, which means change directory. So I'm going to move from my home directory into the Fix Gateway directory. And you can see now that that's where I am. I've got the tilde here, and then, which means my home drive, and then I've got a // and then now I'm in the Fix Gateway directory. So that's where I am right now. And then from here, I want to type pip3 space install. This looks kind of familiar. We did this a minute ago, except this time instead of installing Geomag, which we've already done, I'm going to hit the period button here. And that means to basically go through and find everything that I need to run what's inside of this directory and pull down those libraries that are required. So I'm just going to go ahead and hit enter here. And we'll give it a minute. It's going to go out and grab a bunch of stuff for us. So the next thing we're going to do is change directories to get out of the Fix Gateway. So go cd ... which tells it to go up a directory from where you are. You could hit / ... again, and that would take us up 2 directories, but we only want to go up 1. So now we've gone from the Fix Gateway, and then cd ... takes us up 1 level. So now we're back at our home directory here. And from here, I want to go back to the MakerPlane repository, the head of the repositories here. And the next one I want to grab is going to be, let's look at Pi AV tools. This is another requirement that we're going to need, and we're going to do the same thing. We're going to go code and then copy here. So now we're in our home directory again, and we're going to say git clone space, and then you can hit Control-Shift-V, or you could have right-clicked and said paste. Either way is fine. And then I'm going to hit enter, and that's going to go out and create a new directory that it's just pulled from over here. And here it is, the Pi AV Tools directory. From our terminal window here, we're going to change directories again, and this time we're going to go into, you guessed it, the Pi AV Tools directory. And here again, we're going to say pip3 install period. And it's going to go out and grab any requirements that it needs. It looks like we probably don't have too much to grab anyway. It did go out and grab another Pi AV tools library, and it's installed that as well. So good. So we'll go change directory again, go up one level, and then finally we're going to go to MakerPlane again. And the last one we want to install is this Pi EFIS. Same thing, we're going to say code and then copy. So again, from our home directory, so we've gone up one directory here with the last command we wrote, and we're going to say git clone and then Control-Shift-V, or again you could right click on it and say paste, either way is fine, and we'll hit enter. And now we have created another new directory here that's called Pi EFIS, right? So we're now going to change directory into Pi EFIS, and we'll do, you guessed it, once again, pip3 install. Let's see if it requires any additional things. It looks like it does. Looks like it's complaining about something here. Zip build.api. Well, we'll go on and see what happens here. At this point we have the fixed gateway installed, we have Pi AV tools installed, and we have Pi EFIS installed. Those three applications should be all that we need in order to make this all work. So the next thing I'm going to do, I have my Raspberry Pi here that's been configured to be a Stratux device. This is incidentally another open source project. You can download an image to put on a little SD card that goes into this device. It's just a Raspberry Pi inside that has a couple extra pieces of hardware. There's a couple of radio interfaces for the two frequencies for ADS-B, and it also has a GPS dongle that plugs into a USB connector on that Raspberry Pi, and then it also has an AHRS chip that's plugged into a couple of pins on the Raspberry Pi as well. So that being said, I'm going to go ahead and plug this in, which is going to power on the Raspberry Pi inside. And I'll give it just a couple of minutes to do that. It's going to start up. It'll probably take, I don't know, 30 seconds to a minute to start. And in the meantime, I'm going to click up here to change my wireless connection. I'm going to say select network. In a minute, we should see one that says Stratux. There it is. We're going to connect to that. Okay, you can see that here we now have an IP address assigned to us, which is 192.168.10.47. So that's actually been assigned to us from the Stratux, which is acting as what they call a DHCP server. So it's handing out IP addresses. So what we can do now is open up a browser here, and we can say 192.168.10.1, and that's our Stratux device. Go ahead and hit enter, and here we can see the front page of our Stratux. So for example, we could come here and say GPS/AHRS, and if I move this around a little bit, you can see that it's changing positions, and the AHRS chip is working, which is great. So that's one way you could get some data out of your Stratux. You can just go right to the home page of it. But we actually want to put this into an EFIS screen. So next thing we're going to do now, we're going to go ahead and go to our command line here, and we're going to say change directory ... and then we're going to go change directory to the fixed gateway. Hit enter, and from here we're going to run, if I go ll, it'll give a list of everything that's inside of that directory. If I go ./fixgateway.py, what this is telling it to do is, if I do a /, I'm saying I want to execute a program from this directory. So the dot means this directory. Remember, if we had ... that would mean go up a directory and do something. But if I hit /, that means from this directory, I want you to hit this file and do something with it. So I'm going to go ahead and hit enter here. And you can see that it says running Stratux plugin. So at this point, it's ready to go. It's running the Stratux plugin. It's actually listening for data from the Stratux. And then I'm just going to open another terminal. So if I hit Shift and then click on this terminal button here again, it's going to bring up a new terminal window. I'm going to go change directory, and this time I'm going to go to Pi EFIS, and then we can hit LL again, which gives us a list of everything that's in there. I'm going to say ./Pi EFIS.Pi, and this should open up a copy of Pi EFIS. And as I move my Stratux around, you can see that it's showing the information the way you can see the ball going back and forth. You can see the attitude indicator going back and forth, up, down, side to side, whatever we do here. If I click on the show button here, it's going to bring up a bunch of buttons. We can change to a different, let's go to basic here, and that's going to change to a different set of buttons, so either main or basic. Let's change to the PFD, which actually includes some engine monitoring stuff over here. We can go to just the engine monitoring system here, and we can see a little more specific details about the motor, the engine. We can go to a 6-pack if we wanted to do that, and we can see all of this. Again, as I move the Stratux around, we can see that the attitude indicator moves around. All right, so now let's go ahead and talk a little bit about how to change some of the settings that we have on Pi EFIS. This is kind of an interesting thing. There's a lot you can change with just a config file. Like for example, right now you'll notice I can't really close this down. There's not really a way for me to get out of this program easily. So what you'll have to end up doing is hitting the Windows button here and then just closing it to get out of it. Let me do this again. There's a little X that'll appear here if you hover your mouse over it, and then hit escape. And you can see that it did stop here. So what we want to do next is we're going to go into the Pi EFIS directory, go under, so it's under home/Pi EFIS, and then Pi EFIS again, so you're going into another layer here, and then under config. So there's several config files here that you can edit. By default, it's going to run this one that's called main.yaml, and so we'll open up this YAML file. And if you're not familiar with YAML, it looks a little bit like Python. If you've used Python before, basically sections are delineated by tabs. So you can see here it starts with main, and then a colon, and then 2 spaces to show everything that's within the main section here. And then you go back 2 spaces and start with menu. Menu is the next section of our config file, and then there's 2 spaces, and then you can define different numbers of menus here. One of the things I like to do first when I'm messing around with this is to go to this full screen size. So under main here, if you look for screen full size equals true, I like to change that to false. And then there's another spot down below where you can actually change the size. I'm sorry, it's above here, where you can actually change the size of the window that you're working with. We'll leave it at 800 by 480, but I'm going to turn it to false here, and I'll show you why. I'm going to have to close this down, so I'll hit the Windows key and then close this. And then if I restart Pi EFIS here, okay, now it's in a window, it's not full screen, and I can open and close it at my leisure. I can blow it up to full screen if I want to see what it looks like. Typically you're going to change this screen height and width numbers to match whatever screen it is you're using. So in the case of my 7-inch screen that I bought, I usually set this to 1024 by 600 because then it fills up the full screen. You can see what your default screen is going to be. In the case of, here's your EPFD screen. So if I go here and then hit basic, that's what this button does. It brings up that screen. If I just want to see the PFD, which is, it actually shows some engine monitoring information as well, you can do that. If I wanted to go to a six pack, I can do that. And so all of those menus here are right in this file right here as well. So we've got menu, and then under menus, there's several menus that you have. And so we have a PFD menu, which shows this button right here. We've got hide. Let me see if we go to the main here. So we've got hide, we've got back, we've got next, and that all is shown over here in our config file. So we've got hide, back, next, EMS, units, and basic. If I go back to the basic menu and click here, then we've got the same thing. We've got the hide button, we've got the PFD, we've got the EPFD, which is this button right here. We've got EMS6 main. And then we have a different show menu here. So if I were to hide this menu and hit show again, depending on the menu that I'm on here, so this show menu is going to report back. If I click on the hide button, it hides it, and that puts us into this menu. Basically, there's no other buttons except for this button right here that we're defining. And that button is going to show the basic menu. So if I click on that, it's going to say show basic menu, and there we are. It just pops us back up to here. If I want to say, if I'm on the PFD menu, so if I hit main and then I hit hide, so what we've done is we've clicked here on this hide button, which has made it disappear, and what that tells it to is to show the show menu, which is this one right here by name. And then if I click on this button, the show button that's a part of that menu, it'll take us back once again to the PFD menu. All right, so you can really get in here and customize what you want to see. So if I wanted, for example, to never see the, I don't know, the EPFD screen, I could actually hit Shift and add, I'm commenting that out with this pound symbol. And so now that basic menu is only going to have 5 buttons instead of 6. If I don't ever want to see the 6-pack again, I can do the same thing. And then I would save that, and then close out of Pi EFIS, and then restart it, and it's going to go back to that again. And if I were to go show and hit the basic button here, you'll notice that all those buttons that used to be there are now gone. I know that my screen size is 800 by 480, so that being said, I can move my buttons around on the screen to a place where I would prefer to have them. So for example, if I don't like the amount of space that's between these, if I just want to have 0 space in there, I can actually cut this down to, let's say, 110. Save that, click X here, restart. And now my buttons are much closer together than they were previously. Here's kind of another fun little hint. If you have you'll notice that if I click on it, and if I'm on the PFD screen here, it hides the true airspeed numbers that are hiding underneath here. And it doesn't matter what I do, it's never going to be there. But I've got a little bit of real estate over here where I could actually move these buttons. And unfortunately, if I do that, if I hit the hide button, it all just pops back to the same place. But an easy way to get around this is, first let's move this to, let's say, 800 minus, how wide are our buttons? 100, 110. So whatever 800 minus 110 is, so we'll call that 790. No, 690. And we'll make our top margin, instead of 480, we'll move that up to, I don't know, 420. We'll make that 430 or something like that. That'll move it down a little bit farther. And then instead of having our button spacing at 110, let's go negative 110. Save this out. And then if I replay this, so now our buttons are over here on the right, and if I click it, it's just going to play them back in opposite order. It's going to move it negative 110 from this first one over here. So it kind of knocks it out of the way. If I decided to do that and then go to my regular PFD screen, you can see it's no longer blocking the true airspeed value here. Anyway, this is kind of a fun little thing to do there. You can also have buttons to do different things. So for example, if I wanted to go to the next screen or the previous screen, I can actually, from in here, I can actually, let's say show, if I hit A, it'll move in one direction. If I hit S, it'll move the other direction. Just toggling through those windows. If I wanted to hit the M key here, it would change the airspeed mode from true airspeed to ground speed to indicated airspeed to true airspeed. It'll toggle through those. Here's a cool one, the bracket key on your keyboard. You can actually change your barometer setting. I think that by default it's 29.92, but if I tap on these brackets, I can go up or down. You can see this is changing as I tap those buttons. So that'll work well if you're actually using air pressure for your altitude reading here. In this case, it's just using the GPS, so that's not going to change as we change air pressure. It's going to give us a reading of what it thinks we are based on our geo position with GPS. So here is a list of all of the different screens that we can have enabled. You remember I got rid of, like for example, the 6-pack was no longer part of our list here on the buttons, but I can still hit A or S and get to it. So what we can do is we could actually disable the 6-pack here by the same thing. We can hit pound for each of these lines and then save that, and then we'll go ahead and restart Pi EFIS. And as I do that, I can go A or S, and you'll never see that 6-pack again because it's not actually loading that into the application anymore. Anyway, there's lots of stuff in here that I haven't even scratched the surface of yet. You're welcome to go in and play around with it more. Another thing we probably want to look at is the fixed gateway configuration file. So if we go over here and we click on Home, and then we go to the fixed gateway config, you're going to see there's a whole lot of config files that are inside of this directory that come as part of your download from the Git repository for fixed gateway. By default, when you start up the fixed gateway, it's going to open this file, the default.yaml file. So if we double click on that, you'll notice up here it's going to look for a database file, which is going to be inside of this directory here. And then there's an initialization file, this INI file. Right now it's set to look at this one called the rotax582.ini, which is this file down here at the bottom. And if we open this up, this will actually set some values by default when you start up the fixed gateway. So for example, our tachometer, let me run Pi EFIS here again. So if we were to go to our engine monitoring system, you can see that we have a gauge here that's going to kind of turn up here like this. And there's a yellow mark and a red mark, and there's a minimum and a maximum. And that's what these numbers here are for. You can actually set the bounds of that gauge. So it's going to start at 0. So where this arrow is sitting at 0 right now, that's where the bottom of it. If this goes all the way up to its highest reach right here, past the red and kind of just where the red goes into black here, that's going to be 7,200 RPM. So that's going to be where the gauge stops reporting. And then our high warn, so that's where the yellow mark begins, is 6,800 RPM, and the tach high alarm, that means where it's going to be into the red, that's at 7,000. So you can kind of go in here and set a lot of the bounds for all of these gauges. You can do that for all of these. Going back over here, another cool thing you can do with this default.yaml file, or any of the YAML files in there, is you can adjust things like what kind of connection you want the fixed gateway to make. So you're always pretty much going to want this net fix. Basically this means you're allowing other nodes to connect into the fixed gateway to pull data from it. In this case, Pi EFIS is one of those nodes that's going to actually be able to connect to the fixed gateway using an IP address. In this case, this host IP address right here, if you set it to 0000, that means that all of the available IP addresses on this, wherever you're running fixed gateway from, are going to be accessible for use to connect nodes into. So there's an open source flight simulator called Flight Gear. You can actually set this up to work with Flight Gear. Same thing with X-Plane. And the way you turn this on is you just say, change this no, type in yes here, and then save your document. And that's going to try and reach out to the IP address that you set for your X-Plane simulator, wherever it's running. There's some information about how to do this. You go into your net connections menu of X-Plane, and you have to turn some things on there to make this work. And then you just say yes, and then your fixed gateway is going to be pulling data from X-Plane, which then can be shown on a Pi EFIS screen. So you can actually have like a separate display running with your simulator, which is kind of cool. CAN fix, this is if you have a CAN bus connected to it. Right now it's turned off, but if you watched my last video, you saw that I was able to integrate my angle of attack sensor into the MakerPlane ecosystem. I turned this on, and then I had to make a change here. It's using SocketCAN. That's a library that connects to CAN devices. And then I had to change this from vCAN 0 to just CAN 0. There's a bit more to CAN. I'm not going to go over that in this video, but this is how you do that. You connect it to a CAN device that's plugged into this computer with a USB cable. So with the enunciation flags, I believe that this is how you can tell it when to make X's across the gauges. If, for example, one of your sensors isn't reading properly, it's better to say, basically placard it as being in op than it is to look at bad data and maybe make poor decisions in the cockpit based on data that's not correct. So you can kind of set some of this information here. I haven't played around with this very much either. So with this test here, you can actually set up, if you were to change this to yes, it would actually push some mock data into the fixed gateway, which would then appear on Pi EFIS. It's a little bit squirrely. I was playing with it before, and it just is really erratic. So I didn't mess with it too much. If you happen to have some other sensors that are plugged into the Raspberry Pi, if that's what you're using for your fixed gateway, you can connect sensors into the GPIO pins that are on the Raspberry Pi to pull data off of them, and you can actually use that right here and tell it what it is that it's doing. Anyway, lots of stuff in here that you can get in there and play with. I just wanted to kind of show a few things. The one that you're going to want to see for this particular video is the one down below. It looks like it's around line 306 of the default .yaml file, and that's the Stratux configuration. If you don't want to listen to Stratux, you can just type no in here. But for demonstration purposes in this video, I have it set to yes. By default, that's what comes when you download it from Git. It's going to default to trying to connect to a Stratux device. And it knows the IP address based on whether or not you're connected to your Wi-Fi for your Stratux. So in every one of those Git repositories, you'll see that there's a docs folder in there as well. It's probably in your best interest to go in there and look through those documents at least and kind of get a broad picture of what it does. Some of the documentation's a little bit iffy in there. I've noticed that I've had to read through kind of all the documentation to kind of get to the point where I understand how things work. Just because they kind of conflict in a couple of spots, and that just comes down to it being an open source project. Most of the people that work on this are developers, and so they write code really well, and I'm guilty of this myself, but I prefer to write code to writing documentation about my code. Maybe if you're not a developer, that's a way that you can help contribute to MakerPlane. Just go in and keep the documentation up to date or something like that. Contribute that way, because that's often the biggest issue for us developers is sitting down and making it usable for other people. All right, well, that's about where I'm going to wrap this video up. Hopefully this has been beneficial to you. I'm going to start working on the airplane again. Probably going to leave this where it is for now until I get around to the point where I'm able to start building out the instrumentation in my panel and make some decisions when I get to that point. I'll still dabble a little bit, and if you have questions and things like that, feel free to ask, and I'll try to answer them as best I can. So if you're still here at this point, I encourage you to subscribe if you haven't already, and like and share this video. Hopefully we can help to build a little momentum behind this MakerPlane project, and we'll talk to you next time. See ya.